Dear students, today, continue with the previous class. Last class we have studied about the intercooling, effect of intercooling on the efficiency of a gas turbine power plant. So we'll now find out what is the intercooler pressure or intermediate pressure for cooling, to get the minimum work output for the minimum compressor work output. A two-stage compressor with intercooling is shown in the figure. So 1 to 2 is the actual compression in first compressor, whereas 3-4 is the actual compressor in the second compressor. 1-2 and 3-4 indicates isentropic compressor work in compressor number 1 and compressor number 2 respectively. Now for a perfect intercooling, the air coming out from first compressor, the temperature should be cooled from T2 to T3, T2 to T3 equal to T1, from T2 to T3, T2 to T3 equal to T1. So now we'll find out what is the minimum intermediate pressure for minimum work required. Now let the work done for this two-stage compressor is given by W equal to Cp T2 minus T1 plus Cp T4 minus T3. So neta C1 is isentropic efficiency of compressor C1, neta C2 is isentropic efficiency of compressor C2. Then WC equal to Cpa by neta C1, T2 dash minus T1 divided by neta C1 plus T4 minus T3 is 1 by neta C2 of T4 dash minus T3. So taking Cpa T1 by NC1, T1 outside the bracket, will get Cpa T1 by neta C1 equal to Pi minus Pi divided by P1 raised to gamma minus 1 by gamma, where Pi is the intermediate pressure between the two compressors. And taking here the T3 outside, Cpa T3 by neta C2, P2 by P1 raised to gamma minus 1 by gamma minus 1. Now, differentiating for minimum work, now you will take this. So let us assume that T3 by T1, T3 is not equal to T1 and it is a imperfect cooling. So therefore T3 by T1 equal to K. Assuming T3 by T1 equal to K, we will get WC equal to Cpa T1 by neta C1, Pi by P1 raised to gamma minus 1 by gamma minus 1 plus Cpa KT1 by neta C2, P2 by P1 raised to gamma minus 1 by gamma minus 1. So for minimum work requirement, differentiating this work with respect to Pi and equating it to 0. So differentiating the above compressor work with respect to Pi and equating it to 0, we get d by dpi of 1 by neta C1, Pi by P1 raised to gamma minus 1 by gamma minus 1 plus K by neta C2, P2 by P1 raised to gamma minus 1 by gamma minus 1 equal to 0. This will get, after simplification, will get the intermediate pressure as Pi equal to root P1 P2 K neta C1 by neta C2 raised to gamma by gamma minus 1. So K for perfect intercooling, K equal to 1. T3, we know that for perfect intercooling, T3 equal to T1. Therefore K equal to 1. And for equal compressor efficiency, that is neta C1 equal to neta C2, then intermediate pressure for maximum work output is given by Pi equal to root of P1 P2. Pi equal to root of P1 P2. Substituting this value in the expression for work, you will get total work actual work equal to this Cpa T1 by neta C into Pi by P1 raised to gamma minus 1 by gamma plus P2 by P1 Pi raised to gamma minus 5 by minus 2. So WA equal to actual work equal to 2 Cpa, will get 2 Cpa T1 by neta C into bracket P2 by P1 raised to gamma minus 1 by 2 gamma minus 1. This is the actual work required for a compressor work required for a compressor for a perfect cooling and with equal compressor efficiency for both the stages. Equal compressor efficiency for both the stages and perfect intercooling. This is the expression WA equal to 2 CPA T1 by delta C whole bracket P2 by P1 raised to gamma minus 1 by 2 gamma minus 1. Now the thermal efficiency and work output per kg of air neglecting the mass of intercooled turbine is given by thermal efficiency equal to T5 minus T6 minus T2 minus T1 plus T4 minus T3 divided by T5 minus T4. Then if the actual work equal to WT minus WC and if T3 equal to T1, then thermal efficiency is equal to T5 minus T6 minus T4, T2 plus T4 minus 2T1 divided by T5 minus T4. This is all about the compressor effect of intercooler. Thermal efficiency for an intercooling turbine, gas turbine power plant.